So let's get started with the agenda first. So what I'm going to talk about, I'll talk about MCP servers, the architecture of the MCP servers, then why you need MCP servers, how you can build your own MCP servers, and how you can integrate them with the AI tools as well. And then later we'll have a demo. Before actually starting, I just want to know my audience, how my audience looks like. Can you raise your hand if you are an engineer or a developer writing code? Okay, lots of folks. Anyone who is into SRE, DevOps? Okay, decent audience size. People who are working with Kubernetes? Cool. And any one of you using ChatGPT, Claude, Copilot? I think everyone, yeah. Okay, I just missed one persona here. Any students here in this hall? Okay, a few of them, okay. I think this talk has something for everyone, all the personas that we have. And I'll start with the basic introduction of what MCP is, what problem it's trying to solve, and how you can use it in your day-to-day life. The MCP stands for Model Context Provider, and what this actually means is, if you try to understand this term Model Context Provider, this means that you have a model, a large language model. It can be any model like GPT, Llama, Quinn, right? And what we mean by context is that we are trying to provide some context, that domain-specific context, to these models. And protocol stands for a set of instructions or a standardization that helps in establishing the communication between different systems. So in total, MCP basically sets up a standard so that these AI applications or these LLMs they can talk to each other. You can think of MCP as a USB-C for AI applications, which means that just like you have USB-C on your laptop or your machine, you can integrate any peripheral, any device with the help of the Type-C. You can connect your keyboards, mouse, your cameras, microphone, anything can be connected with the help of the Type-C port. So that acts as a standard interface, and that is what MCP in the world of AI represents. Like I mentioned, MCP provides a standardized way of how these AI models talk to each other. And MCP was developed by Anthropic, which created the Claude application. Okay, so what MCP is, now if I have to give an analogy what MCP means in terms of if you have to correlate with this web development. So you can think of this as what REST is in web development, the REST APIs. Think of MCP is what in the term of AI domains. Now, why someone needs MCP? Why you should care about MCP? You can go to ChatGPT, Claude, right? Or GitHub Copilot, right? Any of these tools, and you're going to start interacting or you're going to start doing things from there. But why someone should care about MCP? Now, the real ingredient or the secret ingredient here is that the standardization. That MCP provides you the standardization which enables that all these applications can talk to each other, right? Your client applications can talk to these AI models. And we'll talk about what problem exactly this MCP is trying to solve. So it provides you a consistent way, which means that previously, without MCP, if you don't have MCP, you used to have M-into-N connections, which means for a given model, you will write a separate implementation for a different system. Let's say if you have model A1 and you want to integrate that with Git, you will have an implementation that you are going to write, that how that model should interact with the Git. Second, if you have another model, let's say model 2, which want to talk to cloud storage, you will write that integration. And similar for model 3 as well. Now, if you are not using MCP, you will have to write that integration for all the models, for all the data sources, right? Which gives us that connection of M-into-N, right? Now, once you have MCP, right, it provides you that standardization, which means that you can write implementation one time, and that same implementation can be leveraged by different models to connect to different data sources. So why someone should care about MCP? It provides you a consistent way how these tools and services should interact with each other. And AI models, they often lack of domain knowledge. We often hear that they hallucinate, and we can provide or enrich the information that we want to pass to these AI models by the help of context. So we can provide that context that we are talking or we want to deal with these operations in such a manner, providing them the context. Now I have an example here. Assume that you want to deploy a Node.js application using Docker and Kubernetes. Once you just give this blind statement or blind prompt to any agent, right? it's not going to, it's going to give the response, but maybe not what you want, right? It's going to give a standard deployment specification, but it's going to lack in the terms of how so assume that you want to leverage this thing for your organization, right? It's going to miss on the compliances part, how the secret should be managed, how the compliances should be handled, right? So because the AI models, they don't have those awareness about the context, right, or the domain, right? They don't know about your internal organization policies, and that is where MCP can be used to enrich the context given to these AI models. Let's now talk about the architecture of MCP. When you have to integrate or build an MCP server, you will be having a data sources. Now, these data sources can be your any data source. It can be databases, your local file system, or internet as well. And then you will have MCP server. These are the server that you, as an engineer or a developer, are going to create. They are free, available, open source GitHub MCP servers as well that you can leverage for your day-to-day life. And then you have something called as MCP clients. Now, these MCP clients are programs that maintain one-to-one connection with the MCP server. And then these programs can be running anywhere. We call them as MCP host. So Claude also supports the capability of running MCP servers. You can run MCP servers along with your IDE. GitHub Copilot is a very good example of that. And you can build your own applications like a web app that can connect to MCP servers and start interacting with the sources, the data sources in that case. So like I mentioned, MCP hosts, they are the programs that host the clients. Clients maintains the one-to-one connections between these MCP servers. And MCP servers are actually the programs that are interacting with your actual data sources. Now, data sources can be either it can be a local data source or it can be a remote service that might be running somewhere in your cloud, right? It can be a database, GitHub, Slack, anything which is running remotely. You can use it as a data source. Okay, now we have a fair understanding of what MCP servers are, why someone should care about MCP servers. We talk about the MCP architecture as well, but let's talk about how these MCP servers communicate to each other via the client. So is this visible till the end? I don't think so, right? I'm not sure if I can zoom in as well. Okay, I'll try. So this is a sequence diagram. I'll try to see if I can highlight certain pointers. So this diagram should be able to give some idea how the MCP servers are initialized or how a request is sent to the MCP servers. So whenever there are different personas, this is user, then this is Claude or your AI model, then MCP client, MCP server, and then external server. Now, whenever your MCP client or the MCP client initializes, it basically makes the request to the MCP servers from where it gets the list of all the available tools or all the available capabilities of your MCP servers. Now, once that system is initialized, this usually happens when you bootstrap your MCP host or MCP client. Now, here we are trying to make a query that what's the weather in San Francisco. And now this Claude AI is intelligent enough that whether the request that or whether the query that is asked by the user, does it need a real-time data or not, right? It is able to figure that out. And what it does, it basically the Claude agent in this case, sends that request to the MCP client. And then the request it basically looks for the capability that whether that MCP client has the capability to get the data or not, right? Once it gives that permission to the user, asks for the permission to the user that do you want to really make that request? User grants that permission that yes, I want to grant that permission and go ahead and get the data for me. Once the permission is granted, the request is sent by the client to the MCP servers. Now, the MCP server is going to send that request to the external system, right? It can be weather API, and then it's going to get the response back. The response is now sent back to the client, and from the client, it is sent back to the Claude AI. Now, in this case, at the Claude level, once the request is reached here, or the response is here, it sends that response back to the user with some enriched data, right? We'll see that. So I have a demo as well where I'm going to show you how these AI agents are going to enrich the data. So this is how a request flows when you actually make a request to the external system. Now, let's talk about the transport layer. So the transport layer is the layer which handles the actual communication between the client and the server. And there are two ways how these transports or two mechanisms how you can set up these MCP clients to connect to MCP server. First one is standard input-output transport, which means that, or which basically allows you to run the process locally. In this case, your MCP server can run locally, and your client can also run locally. And it's very ideal for doing up some testing. When you are building up the MCP server, you can do that. In this case, the MCP server and the client both are running locally, right? The second one is streamable HTTP. In this case, the assumption here is that, the whole idea is that your MCP server can run in a remote server. It can run anywhere, maybe in Kubernetes, maybe in some EC2 instance, anywhere. And then your MCP client is making a HTTP call to that MCP server via the MCP protocol and helping you to connect and get the data via that connection. Let's talk about the HTTP-based model here. So when the HTTP-based transport is used, it typically uses a JSON RPC protocol. It's the standard JSON RPC protocol, nothing fancy or new invention here. And your MCP clients interact with the MCP server via that JSON RPC protocol. Now, they can use the standard input-output protocol as well, but the limitation with the standard input-output protocol is that in that case, your MCP server should be running locally to make that connection between the server and the client. Whereas if your MCP server is running on some remote machine in some cloud, then you can use the JSON RPC protocol to connect to that MCP server. JSON RPC is nothing, it's a standard, the protocol which allows you to send the data in the form of JSON response, and it makes the remote procedure calls, which means that the procedures or the functions are stored remotely on those servers. I'll give you an example what's the difference between the HTTP-based connection and the standard input-output-based connection. So if you see, again, not sure if this is visible at the end. So if you see this, the first picture here, this is a HTTP-based connection, and here we are specifying the transport as HTTP, which means that the MCP client who is trying to connect to the server should use the HTTP transport, and then I'm giving the URL on which my MCP server is exposed, and then any headers if my MCP server needs that, right? So here you can set up authentication part as well, where you can send up API keys or tokens if you want to authenticate to the MCP servers. The other diagram that I have here is, this is a standard input-output based connection. And here you don't have to give anything, right? The transport by default or implicitly it's stdio. And here you can give the command, like the command to execute or start your MCP server. So here I'm giving the command as npx and then starting this MCP server, which is Kubernetes MCP server, and giving the version. So this way you can start the MCP server, or your MCP client can start the MCP server. The MCP community is kind of growing at a very fast pace. Every day you will see MCP server available, be it official MCP server or third party, or people in the open source community, they are contributing to this MCP server. I've taken a snapshot of some of so these were alphabetically sorted, so I took the screenshot from there, and you will be able to see that there are lots of MCP server which are available as of now. So now let's try to build the MCP server for Kubernetes, and we'll try to build the MCP client as well. So let's try to build the MCP server first. In order to build the MCP server, I'm using Python in this case. I'm using a package manager called UV that makes life a bit easier. So first I'll be initializing up the project. I'll be doing UV init and then giving the folder name or the MCP server name, which is Cade's MCP server. Now, once I do this, my MCP server or the directory structure or the boilerplate code is ready. What I'll do, I'll add a dependency or a library called fastMCP. Now, this library is going to help me in building up the MCP server with the help of few instructions, right? Few decorators. So once I add that, then I can simply say that MCP server equal to fastMCP server and give the name of your MCP server and do MCP server.run. And once I do this, my MCP server is ready, right? So here you can see that just with the help of one library, which was fastMCP, I'm able to spin up my MCP server. So my MCP server is ready, but it doesn't have any capability as of now. It can't do anything. It cannot connect to any external system, or it cannot do anything for you. It's a vanilla or a blank MCP server. So now let's try to add some MCP tools to it so that it can do actually something for you. So I was talking about this library called fastMCP. This has decorators or annotations. So here is one annotation called @mcp.tool. And in this annotation, you can give the name to your tool the description, and possibly some tags as well. Now, once I do this, you can define your function that what exactly this MCP server or should do. And it's once you add the implementation, this MCP server is ready to be used by the client. So here I'm giving the name as MCP server, or this tool name as list Kubernetes underscore pods, and I've given the title as list Kubernetes pods. And these details will be visible in your client as well. So your client is, whenever your client is making a call, it's going to make the call based on the description that you have given. Like based on the name that you have given, it's going to figure out that on the runtime. And then the function that I've defined here is that give me all the pods in the Kubernetes in the default namespace. And once I do this, I can simply say uv run and give the file name, which is main.py in this case. Now, once I do this, my MCP server is running, and it should be able to serve your request. That's it, right? So the MCP server is ready, but where is client, right? We didn't talk about client. So you can write your client in various languages, or if you don't wish to write your client, then you can use either Claude or GitHub Copilot, because there you don't need the client, because these tools are already capable enough to connect directly to the MCP server side. Again, I'm going to write the MCP server client in Python, and I'm going to show you a demo on how you can integrate Claude with your MCP server as well. So let's try to build a client. And remember, in this case, I'm not going to use any commercial model. I'm using a model which is running locally on my machine, right? So I don't need any internet connectivity in this case. The Kubernetes cluster that I'll be using for the demo, again, it's running locally. So everything is running locally. And even the client as well, everything is going to run locally. So first, I'm importing some libraries. These are some MCP, fast MCP libraries, and the LangGraph libraries. I need them in order to connect to my client. Now I'm defining that, okay, my MCP server is running on this port, and I'm establishing a connection. So once I do this, my MCP client is ready. But let's talk about how to actually call the MCP server. So here, in the first instruction that you see, I'm doing client.listtools. Now this function call that I'm doing here, this is going to list all the available tools that my MCP server is exposing, or the capabilities of my MCP server. Now, it's going to list you all the tools, and in one of the instructions here, I'm actually calling one of the MCP tool, which is list Kubernetes pods. So this was the MCP tool that we created, and here I'm directly calling this. Now this is going to make the call to the MCP server for this particular tool and give us the response back. Now, if you want to connect this to LLM as well, because if you don't do this, right, then it's going to give you data in the normal JSON format, which not everyone can understand. And in that case, we need LLM so that it can transform that response so that everyone can understand in a plain English format. And that is where I'm using a model called Llama 3. It's running locally. And once I start using this model, I'm passing that response to this model. So here you can see whatever, I'm just making the call, passing that query to this agent, and then getting the response back. So this way, you can connect your MCP, you can build your MCP server, you can build your MCP client, and then you can connect with your local MCP models as well. Let's talk about how, once you have built the MCP server, how you can integrate them with your, let's say, Claude, right? So there are, again, if you're using fast MCP, there are few commands that you can use to install that on Claude. You can install that on VS Code and Cursor as well. And if you don't want to use these tools, rather you want to do everything manually by yourself, then you can get the JSON file out of it. And with the help of this JSON file, you can easily integrate with any system that understands MCP, right? So I'll go to the demo part now. Okay, I'll set some context for the demo. So the bottom window that you see, this particular window, here my Ollama server is going to run, the LLM. In this particular window, my MCP server is going to run, and in this window, I'm going to run MCP client. Okay, my LLM is running locally now, and I'm going to start the MCP server in HTTP mode, so that, because in the client implementation, I'm using HTTP. Now, once this MCP server starts running, I can start firing up the query. In this case, I'm using a local Kubernetes cluster, and my MCP server here, you can see it's running on port 8080. Now, the first thing that I'm going to do is I'm going to make a query which says list all pods in the Kubernetes cluster along with the namespace, right? So I'll run this particular MCP client, uv run client.py. Now, once I do, this is going to make the, so here you can see a lot of things happen, right, on the left and the bottom as well. And in a couple of seconds, you will be able to see that a response. So on the top, you can see that I'm printing up all the available tools. Now, in this MCP server, I created a couple of more tools. That's why it's able to list all of them. And in a couple of seconds, we'll be able to see the response back. So here you can see that we are getting all the pods that are there in the Kubernetes cluster. Now, again, I'm going to make one more request here. And this time, I'm going to say that create the Nginx web server on this Kubernetes cluster. So in the default namespace. Now, again, I'm going to run my client application. And this is going to create the Nginx web server for me. OK, so it created that. And if I do list the pod, here you can see that the Nginx web server is available and running, right? I want to show you one more thing. OK, not much of time left, but I'll show one more thing. OK, oh, OK, this is not visible there. OK, this is Claude. And in the Claude, if you go to the settings icon, here you will be able to see all the MCP servers. Now, the K8s, Fabric K8s, MCP server I will disable, and I'm using one more MCP server. And I'll show you that, let's try to make some query to this MCP server. So I'm saying list pods. Let's see if this works. So this is, again, using MCP servers. This is going to list all the pods. This is the permission thing that I was talking about when I was showing you the sequence diagram, that it asks for the permission. And I give it, allow this operation. And it's going to give me all the permission. So here you can see it's listed out all the available pods. And here you can see that enrichment is also happening because my MCP client should ideally have given the JSON back or the response in normal string format. But here you can see that the enrichment has happened, which is done by your LLM in this case. And it has given extra details like the default namespace. And these are the pods which are running in system namespace called kube system and all these things. And here it's saying that there is a pod, OK, Redis, which has an issue of pulling up the image. So let's try to fix this. Let's try to fix this. So I'll say fix this Redis. So I'm asking it to fix the Redis pod, which is crashing. Let's see what it tries to do. So it is able to identify that there is an image pullback error, which means that something related to the image. Let's see this. So remember, all these are tools. All these are tool executions. This is a tool that is getting executed against these parameters. And then this is the response that is given back by the MCP server. OK, it has given us that we are trying to, OK, that pulling an image which is invalid, and it's helping us with that you should use this image called Redis:latest. It has an extra. So the image that we were using, that has an extra. Let's try to fix this. So it's trying to recreate the deployment. Let me allow this. OK, so it was able to do that, and now it's listing up the pods in that namespace. OK, the pod has been fixed. So the problem was that it has extra S, and the solution was that it removed that extra S, and now the pod is running. Let's try to see from the terminal. OK, so this is the Redis pod, and it came up a couple of seconds back, which means that it was able to fix the issue that we had. I'll move back to the presentation now. Last few cents from the presentation that building MCP server is easy with the help of various libraries that are there, but you have to consider a lot of other problems that might come in. I'm not going to talk much about the problems as of now. That's going to take another different presentation altogether. But always think about the security aspect of it, because once you start exposing your MCP servers over HTTP, then you're opening up the door and anyone can connect to your MCP server and start executing commands that were not supposed to be run, right? Someone can send up an instruction that delete, do an rm-rf / in the root directory, right? It can blow up your system. You should always consider setting up the auth for these MCP servers. In the example that I showed you, I have removed that, but there are ways using which you can set up the auth. It can be OAuth or at least as simple as API keys or the bearer tokens, right? Always keep updating with the MCP libraries because the MCP spec is still evolving, right? Keep your MCP servers up to date with the latest libraries. And yeah, that's it I had. Any questions? Up for any questions? If you want to reach out to me, these are my socials. The code that we saw for the MCP server and the client is available on my GitHub handle. You can just find the repository on this particular GitHub handle. Thank you.